Let us now have separation of variables, chapter 2 of differential equation. In the solution of an ordinary first-order differential equation, the simplest is the one in which the variables, say x and y, can be separated. By this, it means that the functions of x times dx is separable from the functions of y dy, meaning we can separate the variables x and y in the equation. So just read on the preliminaries of chapter 2 and we'll go ahead to sample problems and how we're going to go about solving problems in separation of variables. So let us have example number 1. Okay, example number 1. Find the complete solution of the differential equation dy over dx is equal to 2x plus 2x y squared all over y plus 2x squared y. The first thing that we have to do here is to separate the variables. We have to separate the variables x and y. So the first thing that we have to do is dy over dx is to factor out the common factor of the numerator and denominator. In this case, we have 2x is the common factor of the numerator times 1 plus y squared. All over the common factor of the denominator is y times 1 plus 2x squared. Let us now separate the variables by cross multiplying. So if we're going to cross multiply dx, 2x, so this becomes 2x dx, right? And y to dy, we have y dy, okay? And then cross multiply 1 plus y squared to the denominator of y dy. We have 1 plus y squared and retaining the denominator 1 plus 2x squared. And we now have separated the variables. Okay? So, transposing y dy over 1 plus y squared to the right, we have 2x dx over 1 plus 2x squared minus y dy over 1 plus y squared and equate this to 0. Okay? So the next step is to integrate the equations. So what will be the integral of 2x dx over 1 plus 2x squared? In here, this is now in the form of du over u. And the integral of du over u is ln of u plus c. Okay? So what will be our u here? So we have your u is equal to 1 plus 2x squared, and in here, your u is equal to 1 plus y squared. So if our u is 1 plus 2x squared, what will be our du? Differential of 1 plus 2x squared. The differential of constant is 0, and the differential of 2x squared is 4x. In here, your u is 1 plus y squared. Your du, therefore, is 2y. Applying this in the formula, du over u, so if your u is 4x, but we only have here 2x, we have to multiply this by 2 to give us 4, since our du here is 4x. But as we multiply this with 2, we have to multiply this again with 1/2. In that case, multiplied by 2 divided by 2 gives us 1. Here, your du must be 2y dy, but we only have here y. So we have to multiply this with 2. And by 1/2 in the process. So, rewriting this, we have 1/2. The integral of 2 times 2 is 4x dx, that'll be your du, over u, 1 plus 2x squared minus 1/2. The integral of 2 times y is 2y dy, all over 1 plus y squared. And this will give us c if we're going to integrate. So we have 1/2. The integral of 4x dx over 1 plus 2x squared is ln of 1 plus 2x squared minus 1/2 ln of 1 plus y squared is equal to c. Okay? So the common factor is 1/2. So we have 1/2 ln of what do we do in the subtraction of logarithm? For subtraction of logarithm, we have to, if we're going to combine these two, we have to divide. So we have 1 plus 2x squared over 1 plus y squared is equal to c. Okay? Now, let's have it here. Cross multiply. So we have ln of 1 plus 2x squared over 1 plus y squared is equal to 2c if we're going to cross multiply. And we have 1 plus 2x squared over 1 plus y squared is equal to, taking the natural logarithm of this whole thing, this will give us e to the 2c. Okay? Cross multiply again, we have 1 plus 2x squared is equal to e to the 2c times 1 plus y squared. Now if we're going to let c sub 1 be equal to e to the 2c, this equation reduces to 1 plus 2x squared is equal to c sub 1 times 1 plus y squared. So this answers example number 1 of separation of variables. Okay? Now let's have example number 2. Example number 2 on separation of variables. Find the complete solution of L di plus Ri dt is equal to 0, where L and R are constants. Where L and R are constants. Okay? Now, the first thing that we have to do is to separate the variables. Divide everything by L and I. L, I, L, I. So this cancels, and this cancels. So we have di over I plus R over L dt is equal to 0. Since R and L are constants, we may replace R over L with K. Or, if we're going to integrate this, we have ln of I plus R over L, which is K, and the integral of dt is T is equal to C. So ln of I is equal to C minus KT, or I is equal to E raised to C minus KT, or we can rewrite this as E to the C, E to the negative kt. So we have I is equal to, now if we're going to let e to the c be equal to c sub 1, so we have c sub 1 times e to the negative kt. So this answers example number 2. Example number 3. Determine the particular solution of, this is number 3, of e to the x, e to the y dx minus e to the negative 2y dy is equal to 0. Separating the variables by dividing everything by e to the y, we have when y is equal to 0, when x is equal to 0. Nakalimutan ko yung condition. Okay. So separating the variables, we have e to the x dx minus e to the negative 2y dy over e to the y is equal to 0. Simplifying this, we have e to the x dx minus e to the negative 3y dy is equal to c if we're going to integrate this. Okay? So in here your u is x, but in here your u is negative 3y. If your u is negative 3y, your du must be negative 3 dy. So the integral of e to the u du is e to the u. In here, the integral of e to the x dx is e to the x minus, our du here is negative 3 dy. So this must have negative 3 in it. Okay? And then we have to multiply this with negative 1/3 supposedly. Negative gives us positive. So we have plus 1/3 the integral of e to the u du. This satisfies now the formula. So e to the u, we have e to the negative 3y is equal to c. Y is equal to 0 when x is equal to 0. So this will give us e to the 0 plus 1/3 e to the negative 3 times 0 is equal to c. E to the 0 is 1 plus e to the 0 here times 1/3 is equal to c. Your c therefore is 4 over 3. Substituting this value here in the solution, we have e to the x plus 1/3 e to the negative 3y is equal to 4 over 3. Simplifying this further, we have 3 e to the x plus e to the negative 3y is equal to 4. So this answers number 3 on the separation of variables. Now let's go to example number 4 on the separation of variables. We have number 4. Find the complete solution of x cosine square y dx plus tangent y dy is equal to 0. Separating the variables, we have x dx plus tangent y dy all over cosine square y is equal to 0. Using your identities in trigonometry, we have x dx plus 1 over cosine square y times sine y over cosine y, which is tangent, dy is equal to 0. Simplifying, we have x dx plus sine y dy all over cosine cube y is equal to 0. Before integration, let us determine the formula that we are going to use in integration. This is actually a power formula equation. So we have x dx plus cosine y to the negative 3 sine y dy is equal to c if we're going to integrate. So the integral of x dx is x squared over 2. Now, let us have cosine y to the negative 3, which is actually the same as cosine cube y in the denominator, times sine y dy. So this is now in the form of x to the n dx, which is n times x raised to n minus 1. Correct? Mali. This is just the integration. So if we're going to integrate this, we have x raised to n plus 1 over n plus 1. Integration. So this becomes cosine y to the negative 3 plus 1 over negative 3 plus 1 is equal to c. So this is x to the n dx. Your dx is sine y dy. Okay? But what is the integral of cosine? Differential of a cosine is negative sine. Negative sine. So this must be negative. So we have x squared over 2. Negative negative is positive. Cosine y to the negative 2 over 2 is equal to c. Or we have x squared plus cosine squared negative y is equal to 2c. Okay? Or we have x squared plus 1 over cosine squared y is equal to 2c. But what is 1 over cosine? So we have x squared plus, what is 1 over cosine? That is secant. So 1 over cosine square y is secant square y. That is equal to 2c. Okay? If we're going to let 2c equal to c sub 1, your final solution yields x squared plus secant square y is equal to c sub 1. So this answers example number 4. Now let's have example number 5. Find the general solution of, what is this? dy over dx is equal to 2 minus y squared over 2 times 1 plus x raised to 1/2. Right? Separating the variables, we have dx over 2 times 1 plus x raised to 1/2 minus dy over 2 minus y squared is equal to 0. Okay? So, we may take 1/2 outside the integral sign. So we have dx over 1 plus x raised to 1/2 minus dy over 2 minus y squared is equal to c if we're going to integrate this. So what will be the integral of dx over 1 plus x raised to 1/2? So let us simplify this thing. So we have 1/2, the integral of 1 plus x raised to negative 1/2 dx minus the integral of 2 minus y raised to negative 2 dy is equal to c. If this is a power formula, this is now in the form of u to the n du. But what is your u? Your u is 1 plus x. The derivative of 1 is 0. And the derivative of x is dx. So okay na tayo dito. In here. Again, this is in the form of u x to the n dx. Or u to the n du. So if your u is 2 minus y, your dy must be negative dy. Okay? So if this is negative, we have to multiply this with a negative. This becomes positive. Using the power formula, we have 1/2 times 1 plus x raised to negative 1/2 plus 1 over negative 1/2 plus 1 plus 2 minus y to the negative 2 plus 1 over negative 2 plus 1 is equal to c. Okay? So 1/2 plus 1 is 1/2. So we have 1/2 times 1 plus x raised to 1/2 over 1/2. This cancels. Minus 2 minus y raised to negative 1 over actually negative 1. Okay? So, this must be positive. If we're going to multiply negative with positive, this becomes negative and that will be positive is equal to c. Or we have 1 plus x raised to 1/2 minus 2 minus y raised to negative 1 is equal to c. Or if we're going to simplify this, we'll have 1 plus x raised to 1/2 minus 1 over 2 minus y is equal to c.